Have you ever wondered if everything you know about space is true? Welcome to a myth-busting journey that promises to rocket you straight into the heart of scientific truth. Today, we're setting our sights beyond the stars to explore and debunk some of the most popular myths that have long fascinated and misled space enthusiasts. From black holes acting as cosmic vacuum cleaners to the supposed visibility of the Great Wall of China from space, these myths have woven themselves into the fabric of our cosmic curiosity. But how much truth lies behind these tales? With the insights of astronauts and space scientists, we're peeling back the layers of fiction to reveal the fascinating realities of the universe. Throughout this episode, we'll dive into expert interviews that promise to enlighten, surprise, and perhaps even change the way you view the cosmos. So buckle up and prepare to have your cosmic knowledge challenged as we unveil the truth behind these space myths. First up on our myth-busting journey, black holes. Are they really the universe's vacuum cleaners? Imagine a cosmic entity so mystifying that it bends not only the fabric of space but also our understanding of physics. Black holes, often depicted in popular culture as monstrous vacuum cleaners, sweeping up everything in their path, are actually much more discerning in their interactions. To understand why black holes aren't the indiscriminate cosmic vacuum cleaners they're often made out to be, we need to grasp the concept of gravity. Just like planets and stars, black holes exert gravitational pull, which affects nearby objects. However, they don't suck things in any more aggressively than any other object of comparable mass. Let's put this into perspective. If the sun were suddenly replaced by a black hole of the same mass, Earth wouldn't spiral tragically into this new black hole. Instead, it would continue orbiting around it, just as it orbits the sun today. This is because the gravitational pull from this hypothetical black hole would be identical to the sun's gravitational force, as long as the mass remains consistent. A space scientist explains, black holes do not act as cosmic vacuum cleaners. Their gravitational effect is selective and only influences objects that come too close, much like any other massive celestial body in the universe. The misconception likely stems from the dramatic visual of a black hole's event horizon, the point beyond which nothing can escape. While it's true that anything crossing this boundary is irretrievably consumed, it's crucial to understand that you'd have to be extraordinarily close for this to happen. Most of the universe's matter remains completely unaffected by black holes. Understanding these nuances helps demystify black holes and corrects the hyperbolic myths surrounding them. Far from being the menacing, all-consuming forces often portrayed in movies and books, black holes are just another fascinating feature of our complex universe, obeying the same laws of physics that govern everything else. So, black holes aren't the cosmic vacuum cleaners they're often made out to be. Next, let's shed some light on the true colors of the sun. For many of us, the sun is a familiar sight. It rises and sets in a glorious display of colors, often painted as a vibrant yellow orb in our skies and in our art. But what if I told you that the common portrayal of the sun as a yellow burning ball is not quite accurate? Let's dive into the heart of our solar system. The sun, contrary to popular belief, isn't a burning fireball at all. Instead, it's a massive sphere composed primarily of hydrogen and helium gases. At its core, the sun is the stage for a spectacular process known as nuclear fusion. During this process, hydrogen atoms combine to form helium, releasing an immense amount of energy. This energy travels outwards and is what gives the sun its brilliance. Now, why does the sun appear yellow to us here on Earth? It's all about the atmosphere. Our atmosphere scatters shorter wavelengths of light, like blue and violet, more than the longer wavelengths such as red and yellow. This scattering effect leaves us with a sun that looks yellow from our viewpoint. However, if you were to observe the sun from space, where there is no atmosphere to scatter its light, you would see it in its true colors, a dazzling white. Astronauts who have witnessed this spectacle describe it as overwhelmingly bright and purely white, not yellow. This white light is the result of the combination of all colors of the visible spectrum, which the sun emits equally. This revelation not only changes our perception of the sun's appearance, but also enhances our understanding of the fundamental processes that power it. By knowing the sun's true colors, we gain a clearer picture of the intricate and beautiful mechanisms that operate not just in our solar system, but in the universe at large. Clearly, The sun's true colors are more fascinating than fiction. Can you really see the Great Wall of China from space? Let's find out. Ah, the Great Wall of China, stretching over 13,000 miles, a marvel of ancient engineering and a symbol of cultural significance. It's often said that this monumental structure can be seen from space, but is this statement grounded in reality, or is it merely a romanticized myth? To understand why this belief is so widespread, let's consider the visibility of objects from space. When astronauts orbit the Earth, their view isn't quite like what we see on Google Earth. Instead, they observe the planet from a vantage point where many features blend into the landscape. A space scientist sheds light on this topic, explaining that the Great Wall, contrary to popular belief, is not easily discernible to the naked eye from low Earth orbit. The primary reason? Its color and texture blend almost seamlessly with the surrounding terrain. Unlike urban areas that can be spotted due to their distinct, often brightly lit geometrical patterns, the Great Wall does not stand out as one might expect. Moreover, the notion that the Great Wall can be seen from the moon is even more far-fetched. From that distance, even large geographical features like continents appear as mere patches of color, making something as relatively narrow as the Great Wall virtually invisible. Interestingly, what astronauts do find easier to see are not man-made objects like the Great Wall, but rather natural formations. Rivers, coastlines, and mountain ranges are far more noticeable because they contrast more distinctly with their surroundings. So while the Great Wall might be a giant on human scales, in the grand canvas of Earth as seen from space, it blends into the background, a subtle testament to its integration into the natural landscape rather than standing apart from it. It turns out some landmarks aren't as visible from space as we thought. Movies love loud explosions in space, but how accurate is that? Imagine the most dramatic space battle scene from your favorite sci-fi movie. Ships zooming past, lasers firing, and massive explosions echoing through the cosmos. It all makes for thrilling cinema, but in reality, space is not the place to go for an auditory spectacle. Space fundamentally is a vacuum. This means it lacks an atmosphere, a medium through which sound waves can travel. Here on Earth, sound travels to our ears by vibrating air molecules. In space, there are no molecules close enough to each other to transmit these vibrations. An astronaut once shared an experience during a spacewalk. While tools clanged and metal clinked against metal, the sounds were only heard through the vibrations transmitted via the astronaut suit connected directly to their body. Outside that suit, utter silence. This silence of space isn't just about lack of sound. It changes how astronauts communicate and work. Instead of shouting or talking, they rely heavily on radios and other electronic means of communication. This is essential not just for conveying messages, but for safety during extravehicular activities. So next time you watch a movie with a spectacular space battle, enjoy the drama and the sound effects. But remember, if you were actually out there, floating among the stars, the only soundtrack would be your own breath and the hum of your spaceship. Space might be more silent than cinema would have us believe. What would really happen to you in the vacuum of space? It's a question that fires the imagination and fuels many a sci-fi narrative. While the dramatic depiction of bodies exploding in space makes for good cinema, it strays far from scientific truth. Let's set the scene straight with insights from space science. Contrary to popular belief, your body would not explode in the vacuum of space. Human skin is surprisingly resilient and can withstand the lack of atmospheric pressure for a short time. However, don't be misled into thinking space is a safe haven without proper gear. Exposure to the vacuum of space presents real dangers. The most immediate threat is the lack of oxygen. Without a spacesuit, you would lose consciousness within 15 seconds due to hypoxia. That's oxygen starvation to you and me. And while you might imagine drifting peacefully into oblivion, the reality would be far less serene. Extreme temperatures would pose another critical challenge. Depending on your location relative to the sun, you could be subjected to intense heat or extreme cold. In sunlight, temperatures could soar to over 250 degrees Fahrenheit, while in the shade, they could plummet to minus 250 degrees Fahrenheit. Additionally, without atmospheric pressure, any remaining air in your lungs must be exhaled to avoid lung damage. a process that must be managed very carefully to prevent injury. Space is indeed hostile, but not in the ways many imagine.